So I'd just like to thank FEAA for all the great work that they've done and helping us along the journey, getting the message over that actually there's a really big resource that we're currently missing. And this is all about how we access that resource and how we actually scale the equipment to make sure that we can offer it to every farmer. And that means globally. So you might notice the CNH part of the presentation here. CNH are now the majority shareholder of Bennamann. And we are now in the process of using together the muscle of a huge industrial company to scale up into the global market. So something really passionate about is that we developed all of the things you're going to see here were developed in Cornwall by an engineering team. And I'd like to thank Cornwall Council specifically for taking the leap of faith and understanding, in particular, Caroline, as you've just heard, understanding the potential opportunity. And at the time when they took that leap of faith, that was definitely not proven. The company came about partly because my background is actually in climate science. I worked in the 80s and 90s on satellite technology, which was being developed to look at initially the ozone hole, and then they started to see the very first onset of climate change. So understanding a lot of how the atmosphere affects the planet's temperature is something that I was very passionate about. And when I came across this issue of fugitive methane from slurry and manure, I thought, what an opportunity, but also it was something that is really close to my heart. So this year we are now in the process of expanding the business, primarily in Cornwall and Devon. And our purpose is really to provide clean energy for hardworking farmers. They're tirelessly transforming agriculture, and that will continue for generations to come. What we solve is this. So there's been a lot of talk about biogas that isn't there. And I can tell you for a fact, it is there, and we can prove it. This is in the middle of February on a lagoon near Launceston. It's been there since 1977, and it's been doing that ever since. And it's been doing that 24 hours a day, 7 days a week, 365 days a year. And we can tell pretty much exactly how much methane is coming up. And I can tell you for a fact there's about £2.50 worth of methane has just gone off in this slide. And if you look to the right, actually you can't see because the label, there's another boil that's gone off, which is of a similar size. And that is the problem that we have to solve, because no one is aware or was aware that this was actually going on. And of course, now we've got the issue where, because farmers are struggling to deal with the other issues, such as increased rainfall, I'll talk a little bit about that. They are now starting to get to a point where they're leaving the sector, and we are starting to see an exodus of dairy farmers. So what I'm going to show you is something that is nearly truly circular farming, to the point where the only thing leaves the farm is carbon, activated carbon. And the only thing that comes onto the farm is vegetable oil that's used in the compressors. There's no diesel on the farm. And I shouldn't lie, that's not absolutely true, not quite there yet. But I can tell you one thing, a green tractor's been sent back. There is no longer a green tractor on that farm. There's only blue tractors, and they're on methane. So the first thing we have to do is, accept that there is methane there, because otherwise you can't generate a business around it, because but what we found was actually the covers themselves produce so many savings for the farmer and actually protects the environment of the farm greatly without any energy. We started out on an energy journey and then found actually we can help the regenerative farming journey as well. So initially the livestock produce slurry. We put a cover on the lagoon and capture the fugitive methane. So I must stress, this is not an anaerobic digester. We are not promoting the production of biogas. We are simply capturing the fugitive methane and the CO2 which is coming off. Now, there will be times in the future, and someone mentioned putting food waste in. That would be an absolute game changer for farming, because if we could take food waste and safely mix it with slurry, you would be able to massively increase the amount of methane that would be captured. But at that point, we're not there yet. So the difference about Bennamann is we've based our whole model on vehicle fuel, because we can then claim the RTFC. So we take that dirty biogas, we take out the hydrogen sulfide, we dry it a little bit, and then we store it above the lagoon or next to the lagoon in some sort of clever gas storage bag. And what that allows us to do is we can take that really expensive piece of equipment, the mobile gas processing plant, which the farmer doesn't buy, but we own and operate, again, remotely. We can take it to the farm when the store's full, and we can empty it in a day. So if it takes a week to fill, that mobile processing plant can go to 6 farms. And so the cost of that and the operation of that is spread amongst the whole community of farmers. And so we're building up this cluster network of methane producers. And we're now starting to exploit the methane technology that's coming out of New Holland and CNH and Fiat Powertrain. And because of that, we can then use that methane in either generators or tractors, and these are produced on production lines en masse, and it's used using quality control levels which allow them to make the same products over and over and over again, which is really important if you're going to scale, because you can't afford for these things to go wrong. And then unexpectedly, what we found was when we give the farmer 6 months storage for his slurry, the digestate that comes out is really a very potent natural fertilizer which retains the bulk of all the nutrients that the grass has taken up. And because the farmer's got 6 months of storage, he can spread it when he wants to use it. So he can time that exactly with his harvesting. So whilst it's a very potent fertilizer, it's amplified because he can spread it when the soil accepts it. And so this means he's saving typically 60% of his fertilizer costs. I'll give you an example for the first farm, which is actually Trenance. Unfortunately, Kevin and Katie weren't here to show you this, but this is the first farm which we've now been operating for 3 years. And this is the data from the second year. And the farm started off before we went onto the farm and captured the methane with a net zero CO2 emissions of 734 tons. We believe when the numbers come in by the end of last year, because they're now using all of the methane to power 2 tractors on the site and also generate the electricity for the milk, and they put in lots of hedges and trees and done a lot of other stuff, we think that farm is going to be less than zero. Okay, so for the first time you've got milk which will be negative, but actually in 2023 we know that the milk had gone from around about a kilo of CO2 per litre down to 0.13, which is quite incredible for a semi-intensive farm. But what we're also seeing is really big benefits in terms of operational savings. So slurry spreading costs have gone down by 2/3 because A, there's less to spread, and B, it runs through the equipment. And I should say these systems are sealed, so there's no ammonia loss because we're capturing all the gas. So we're seeing savings from the slurry, we're seeing savings from the fertilizer, we're also seeing fuel savings for the vehicles and electricity. So the farmers are saving from their operations around about 50k a year, and that's for a 120 head farm. We're starting to see increased worm count in fields that are being tilled. So this is something that's really interesting as well. I wouldn't say that we fully understand it, but I'd like to thank the John Lewis Partnership, Waitrose, for actually also taking a leap of faith. And 3 years ago, I think Andrew's going to talk a little bit about it. Oops, sorry, that may not play. That is supposed to be a video. So I'll let you go online and see that. Basically, one of our systems is actually a Letford farm, which is the John Lewis Partnership farm. And very recently, the John Lewis Partnership and Waitrose announced that they are, by 2035, all of their produce will be regeneratively farmed. And I'll let Andrew talk a little bit about that. So what does it start with? Well, it all starts with what we call the smart cover, which is eligible for the slurry investment grant, which is around about £34 per metre. This is the latest installation that's just gone onto a farm in Cornwall. This is very, very close to being production. So this is the biggest challenges you face. Some of these lagoons are very, very large, size of a football pitch, certainly in some instances, but they are producing huge amounts of methane. So I should say each of these domes filled up in 2 days. Okay, there is no way the biology of that slurry changed in 2 days. That is the gas that was coming off that slurry when it was put on. The smell immediately disappears. Okay, and we know that because it's sealed. So the really exciting thing about this is that it is completely scalable, and it's also made in a production line facility. So each one of these tiles is around about 10 meters square, and they zip together using a really clever technology so that we can actually start to cover some very big lagoons, which is extremely exciting. But again, it's in a production facility. So these are now made under quality control standards. So fueling a tractor, one of the greatest challenges was really, can you really replace diesel on a farm? Because diesel is incredibly energy intense. Some of you may know that 2 years ago with New Holland, we demonstrated the world's first liquid methane tractor. And there's a man sat over there. You can thank Alistair Walshaw for setting that whole ball in motion. So we now know that with liquid methane, we can actually approach the same autonomy as diesel, all again from the farm. But at the moment, we have a compressed methane tractor, and you can see on the front of that, it has very similar autonomy to a diesel, but it does need an extra fuel tank, which goes on the front. On the right-hand side, you can see the mobile upgrader, which I'll show you, which has now been operating for 3 years. So people said this technology wouldn't be reliable. How do you move it between farms? Well, I can tell you that system is going to be retired very shortly, but that has been operating every day, more or less 4 or 5 days a week, going between some farms in Cornwall. It's delivered, plugged in, and then the gas is processed and upgraded into methane and taken from the farm. So today, what do you do? How do you use a CFM? We call it compressed fugitive methane. We don't use compressed natural gas. It's not natural gas, it's fugitive methane. So CFM is what we sell. This tractor has been on the farm. It's done 110 hours. Kev's got another tractor, which has been there for getting on for 2 years now. This is my tractor, actually. And what I did was I was able to modify it because it's my tractor. I modified it so that you could take the fuel tank on or off the front. And Kevin's been using it around the yard, doing a feed wagon, but actually he just did his full cut of grass on the farm. So 2 weeks ago, he spent a whole week processing it, doing everything that a diesel tractor would do. And when he needed it, he would put the fuel tank on and off. The really interesting thing about that is 110 hours of fugitive methane use in a tractor actually offsets 180 tons of CO2. Just to put that in your mind, 180 tons of CO2, right? It's absolutely massive. So what we've tried to do is develop a model, and it hasn't been easy. But we wanted to make sure we had an offering for small farms as well as the larger farms. And that was one of Bennamann's goals right from day one. But unfortunately, the technology, as we go into production, it hasn't made it cheaper initially. It will do as we start to go to scale. But actually, the biocycle has gone up in cost because it's now CE marked, it's fully certified, and we're using a lot of off-the-shelf parts. As these start to go into numbers, those prices will come down. So the actual model on the right, which is Capture, so Capture is the name of the product. Capture Gas is a full installation. So that's basically a farm that's probably got 300 cows plus. That will be fully independent, fully energy independent. There are huge amounts of benefits, including we'll be able to run a methane tractor based on the RTFC credit. That model will move to the left as the technology becomes more affordable. The smaller farms will start to uptake it. But to start the ball rolling, what we've done is we put the cover on, we stop all the rainwater going into the lagoon. That increases the capacity generally by about 50%. So it goes from a 4-month store to a 6-month store. It completely eradicates any loss of ammonia in that because the surface is not in contact with the air. There are other benefits, fertilizer savings and regulatory compliance, as well as slurry spreading savings as well. And in the medium farm, we've actually been working with a little supplier of biogas engines, biogas generators, so we can actually take that biogas and generate electricity on the farm, as we've heard today from the likes of Fugitive and others. And then finally, when there's enough methane, then we can go to the full system installation. I should say that lagoon I showed you earlier with the cover is going to be a completely full gas in energy independent site. So these are some of the benefits for a small farm as I went through, but basically rainwater exclusion is a massive one. Trenance experienced a metre of rain. We have a little weather station on the farm, so we know this. Trenance experienced a metre of rain in less than 2 weeks. Okay, you expect to get 1.8 meters a year. So anyone who thinks climate change isn't here, I'm sorry, but you need to wake up. These are some of the benefits that you'll get. But the soil regeneration is a really exciting one. So when I was at Waitrose last week, I listened to a chap called Gabe Brown, who's into the regenerative farming. He's leading it, very inspirational talk. And we're starting to see some of that soil regeneration benefits, which is really interesting. We don't fully understand it, but the farmers are reporting it back. And they're also seeing increased yield from their grass and much healthier. From the medium to large, well, basically, as I said, energy independence, electric saving. Now, there's a really interesting thing here, electricity. Because we convert it into fuel that we can move in any engine, why don't you have an off-grid charger that charges electric cars, all running on fugitive methane? Well, since April in Crewe, Brett European headquarters has had an 8-vehicle charger running on fugitive methane gas. There is no connection to the grid. It's in the middle of the car park. So now, once you've upgraded it to fuel that can be transported, you can use it in any application. Now, imagine that motorway services on the way up, I paid 80p a kilowatt hour to charge my car. Now I can put that, and that is only in one place because they've got connections to the grid. Well, now you can do that anywhere. Okay, running off methane. Very, very high efficiency engines. So in terms of the industrialization, where are we? Because I didn't really fully understand industrialization, if I'm honest. I came in as a sort of like a space scientist, come entrepreneur. Now I understand it because I've had it beaten into me by the likes of Gilles and Alistair. This stuff has to be reliable. It's got to be made in bulk. And getting to that point has been very, very expensive. Hence, all credits to CNH. They really pulled the finger out and really helped us in that area, which we, as a small startup, we would not be able to do. So first of all, we have the gas filtration system. This sits on farm, CE marked, fully certified, built on a production line. We can order it online. Okay, the farmer has to buy this. So if he's going to the gas, this also brings huge safety benefits to the farm. Complete removal of hydrogen sulfide. We hear all the time about farmers going into the slurry stores, being overcome by the fumes and sometimes, unfortunately, tragically get killed. This removes, that is usually down to the toxicity of the gas, the hydrogen sulfide. So this removes that. Biocycle, mobile upgrading system. So this upgrades around about 50 cubes an hour, goes minimum of 53% methane, which qualifies as fuel grade. It's completely portable, very important because if we leave it on the farm stops dairy farming, we can take it away. Okay, it's got value, but this is owned by Bennamann. Bennamann operate this. They move it from farm to farm. Alternatively, it is stationed on the farm because there's that much biomethane being produced. Then we run an operating fee, but that is owned by Bennamann. In terms of generator power, so now again, as I said earlier, you're not talking about biogas generators, you're talking about methane engines, mass-produced methane engines that are used in trucks and tractors and boats, and that means that we can then access that again, that benefit of scale, and also reliability, emissions. We've had to develop our own. We've gone from 250 bar down to 30 millibar, which is what the generator standard is. We thought there would be a regulator out there that does that, but there isn't, because no one's done this before. Okay, so at the moment we've had to develop our own gas panel so that we can safely feed the generator from 250 bar methane. TerraStore, not a particularly good picture. You'll have to wait to see the real thing. Won't be long. Again, built in production in a factory. Okay, and this is a unique system whereby the bag is always under very, very low pressure, as someone said earlier, less than a millibar. Okay, so there's no issues here at all. Uniquely, it maintains that pressure whether it's a third full or full. Okay, so it's got a very clever system that self-pressurizes. Sorry, these are actually. So, what have we just seen? The most exciting thing for me is that there's a farm in Cornwall, which I hope will become the model of dairy farming. And in doing so, livestock, when you start to see some of the basics of regenerative farming, you need livestock on the ground. It's a fact. Okay, go and look at Gabe Brown, read his book. You can't do regenerative farming without livestock. You can't do it completely. So the livestock coming back onto the land, be it pigs, chickens, and cows, is really, really important. And because if we do it correctly, manage the emissions from those animals, they become the solution to climate change. Because with regenerative farming, you can sequester huge amounts of carbon into the soil. So farming truly does become the solution, not the problem it's currently perceived to be. So thank you.
I know.
Yeah,
I know. Well, thanks, Chris, for that. Has anyone got any questions for Chris? There's loads over here. Any over here? Yeah, over there. Yeah.
Yeah, thank you, Chris. I'm just interested in green ammonia and methane. Actually, the first stage for the smaller units, ammonia, middle one would be methane. But are you still capturing ammonia
No.
So,
Sorry, go on.
sorry, I'll just repeat the question, people online. So the question's around ammonia and methane and sort of clarification around it.
Yeah, so methane. So unfortunately, in the small farm, we're releasing the methane. Okay, the methane is vented off safely, which actually became quite a challenge. So if you put a cover on a lagoon, you really need to understand where it's going to end up. So the cover keeps all the rainwater out, but it also stops the disturbance of the surface, and that's when you get ammonia release. So ammonia will stay in solution in the slurry, provided the surface isn't disturbed. So the cover protects that. Okay. There's ammonia reduction. I can't say it's eradicated because it's not a sealed system, but it will be greatly reduced, probably by 90% or so. We'll probably do some more testing on that just to prove it. But again, it depends on the slurry and lots of other factors that fall into it. No, because the cover literally sits flat on the surface. So the methane is so I should say that cover, the smart cover's got something like four patents pending and in applications. And part of that is about how we handle the gas and the rainwater. So the rainwater falls down and the gas comes up. So I can't guarantee at this stage, but I don't believe the ammonia is mixed in with the methane because the surface of the slurry isn't disturbed during the process. But if it is, it's at a very low level.
And lots of questions. Yeah, over here, Laura.
Because I think if you have a cover on something like a board, you are likely to make the headspace anaerobic act, and I really understood that the cover is but it is likely to be anaerobic underneath, which means you are promoting methane. So it's not an intended digestion as a purpose-made digestion. But also because I think you're pumping it out, the methane. So just back to a presentation in the morning, you would be getting near to the potential of the lagoon to produce methane, so you are increasing that potential.
This is where. Sorry.
Do you want to repeat that?
Yeah. So the question was, by putting on the cover on the lagoon, we are promoting the amount of methane that's being produced. Yeah. If we are, it is again at a very low level. So this lagoon isn't covered. I can go through. I fear a couple of deep dives ago, we've done a huge amount of testing on this in the lab and also out in the field. And what I can tell you about this lagoon is there's a meter of slurry or solids at the bottom, which has been there for the last 20 years. It's never been emptied. And that is producing those big boils. It's basically the gas is still being produced within that sediment. And what happens is it gets trapped on the way up. It forms a big bubble under the sediment and eventually releases. And that's what you're seeing there. That's entirely anaerobic, as you said. But that's not because there's no cover on it. It's because there's dirty water above it. Okay, so there's no mechanism by which oxygen can get into that layer. And by putting a cover on it, we're not changing that at all. So I think there's been this conception that if it's open, there's oxygen. And I can also tell you if there's a crust, increase the amount of or decrease the amount of oxygen getting in there. Maybe a little bit, but it's not. There's no mechanism. What's the mechanism for oxygen to get to that into that pond? Yes. Yes, if there is oxygen in there. Yeah. Yeah, no, absolutely. Come visit. And actually, one of the things we're going to try and arrange for FEAA is when we put a cover on, and I've got a little video I can show you. Literally within hours, the covers go up, right? So that's not biological change. It can't be. You can't have 1,000 cubic meters, cubes of slurry, suddenly change the biology from from aerobic to anaerobic. Where does the bugs come from? Okay, so yeah, by all means come, and we're going to try and arrange when a cover goes on. We're going to get hopefully some like of David and other people who are doing the measurements. they can measure before and after and see the difference. And I can guarantee, I've stood next to it downwind, you put a cover on the lagoon, the smell goes like that, literally instantaneously. So it's going to be an interesting experiment for fun.
I'm just going to a question online from Bill Grace, which I think we've talked about before, which is there an issue with more farmers wanting to move to all year round housing in order to maximise the opportunity, I suppose? And I guess Bill's guessing at the potential for welfare issues, things like that.
Yeah, it's a very good question, and it's actually it's that moral dilemma. I think I've spoken with Neil about it. They're the biggest polluters, so there's more ammonia coming from. So you have a big intensive unit with 1,000 cows. They'll have a lagoon the size of a football pitch. Okay, so to give you an example, a farm that we were on recently is 1,200 cows milking 12 months in a year. That is the equivalent in methane production of 30 Trinance farms, because at Trinance they're only in the shed for 6 months, right? So 12 months you double it. Oh, and by the way, there's 12 times the amount of cows being milked. So it's a very simple calculation. It's nothing really, and we when we capture the methane, basically through 5 or 6 different ways of doing it, you always end up with the IPCC data, which is actually with no discount at all. So it is a dilemma. Do you support in-house, very large farms, some of these big feedlots in America? Personally, I prefer that we focus on the smaller farms, certainly up to 300 or so. At the moment, it's very difficult to get permits for big farms now, because they need to have a big lagoon, and it's very difficult to get those permits. So it's sort of naturally balancing out. But does that answer the question?
Yeah.
I'm not trying to avoid it. It's just a difficult one.
Yeah, it's not necessarily an objective one.
No.
It's like it's a one to chew over, isn't it?
Yeah, I mean the financial returns on a very big unit are going to be much easier to see quicker, which is hence the business model is skewed towards the large farms at the moment.
Cool. Lots of questions over here, I think. Yeah.
Chris, first of all, you've got the solution to our climate change challenges. Just totally 100% agree with you. The regeneration and sequestration of carbon soils are really understand and optimize. Huge opportunity. My question is with regard to further along the food chain. The processing dairy, there is milk waste, and that milk waste would be, in my understanding, a hugely valuable methane producer within your system. Clearly, it's a great idea, put it on a lorry, take it to the farm, it would work, but the Environment Agency have got so many boxes that they have to tick that it's in the impossible box. Can I ask you, what's your view of that? Is it an asset that can be utilised? And is there any possibility the Environment Agency would bring their current rules?
So yes, the question for online is whether there's an opportunity in waste from milk.
Yeah.
Is that right? And about the Environment Agency and how that would all sort of work out, I guess.
Yeah. So the big concern for the Environment Agency, I believe, is going to be biosecurity. Okay. So if the dairy processing is on the farm, the same farm of which the milk is coming from, it just goes in now. And so I think Andrew, I'm not sure Andrew sat next to you might be talking about that, but certainly at Waitrose, the Elected Estate, the milk waste can go in without a permit. If it's being brought in from a processor such as Trinidad dairy onto another farm, you can do it. You just have to apply to the Environment Agency, and there will be certain conditions that you have to meet. But it's certainly something that's going on as we speak. It could be a lot easier, but to be honest, I don't believe it's fully understood. So I think it is a safe way. The stance from the Environment Agency at this stage is actually quite good until this becomes more established as a standard thing. But certainly, if the milk waste is on the farm, then you can already put it in.
So we're running out of time, but I know there were quite a few questions. Can I just check were there any other questions in the room? There were a few over. So there's just one left. Okay, if we just take this one, please, that'd be great.
Yeah, thank you. That was a really interesting sort of in terms of the industry a few years ago. So well done. The biggest question I've always had over this system is how you manage the energy balance when it comes to the biomethane upgrading. How rigorously energy intensive to do it, about your mass balances and 400 watts per kilo of biogas to upgrade, and you've sold up to 600-700 once you bring in the compression.
Yeah.
How are you dealing with that? Are you burning lots of diesel through generators to achieve that, or are you sort of using some of the gas generated and sort of looking at absolute load out and getting there?
Yeah.
So the question is, how do you deal with the energy imbalance? How do you manage that?
Yeah, actually, Biocycle is incredibly efficient. It uses 15 kilowatts to run in its complete power. So we have, you're right, in the early days, we actually used diesel generators. Now we use methane generators using some of the gas that we've upgraded. It's about 15% of the overall gas, which is, and that's partly down to the fact that because it's a fuel, it's not biogas, you can have a very efficient generator. The generator I showed you there, which is off the shelf, is about 27%. And in my back pocket in the yard at China, if I have a 40% efficient methane generator using the same engine that's in the methane tractor. So again, you're accessing that, state-of-the-art engine technology. So I would expect the efficiency to come down. It's good to go up. So you're even using less gas. And then finally, when we go to liquid, it's the same thing. We have we looked really, because it's obviously a big problem, right? If you really want to be able to go on a farm and process the gas, you can't be drawing more energy out of the grid than. So at the moment, it's around about 15%. We hope to get it down to about 12. And if you've got solar, of course, which every barn, in my opinion, every dairy barn should be completely loaded with solar, right? Then you haven't got a problem at all. And we're supplying a battery, I should say, the energy storage. The energy system includes a battery, so even the biogas generators has a battery with a battery management system incorporated into it. So it's not just a generator, it's a power source. So at the moment, I believe Jules might know, I think it's 20 kilowatt hours battery. So for a small dairy, it will probably power most of the dairy in the morning, potentially in the evening as well.
Right, I think we're going to end this one here. So thank you very much, Chris. It was really interesting. And recording.